Bismillahirrahmanirrahim. Greetings. This is going to be an introductory lecture about a mini series of lectures that I'm intending to upload about the concept of sequence and series in mathematics. Now, I will be presenting these lectures at the curriculum of freshman college, mostly for liberal art students, but high school students and also calculus students, they can benefit from these lectures. More rigorous and detailed discussion of this subject is usually belongs to the curriculum of of calculus that comes in the second semester of calculus mostly. I may not go that detail about that. Okay, then let's get started for today's lecture. Now, sequence is an ordered list of objects. Let me repeat one more time. Sequence is an ordered list of objects. The object that we are discussing naturally in all my lectures are numbers. Now, care should be taken to distinguish the difference between sequence and set, because mathematics is a very kind of meticulous subject, and every vocabulary of that we have to take it very seriously. Notice that I didn't say, even though sequence is also a collection of numbers, I didn't use the word set. There is big difference between them. Set is a well-defined collection of objects. The word well-defined means that we know precisely what is in that collection and we know precisely what is not in that collection. And notice that also the order was not mentioned, was not emphasized. Now, for instance, 1, 2, 3, 4, 5, comma, separating them, and 5, 4, 3, 2, 1, comma. These two are same sets. We know exactly what is in there, what is not, and again, the order is immaterial. But these two are two different sequences. And usually bracket is used for both of them, for the set and for the sequence. So again, care should be taken to distinguish between them. So we know what sequence is. And also a collection like 1, 1, 2, 2, 2, 3, 4, 5. This is a sequence, but this is not a set, because set should not have any repeated elements in there. So the collection of objects for the set should not have any repeated elements. If there is, we extract that. But sequence can have all kinds of repeated elements as long as there is a kind of order in there. The order is imposed. Now, series is the summation of the terms of a given sequence. So we may say that every given sequence corresponds to a series, and every given series can be correspond to a sequence. The summation of them. Now I will go to the subject of summation. I also have some, I put them on the board, and that is the compact notation of sigma is used. Now, since addition is a commutative operation, therefore as far as the order is concerned, when we go to series, the order is not imposed. But when we use sigma notation, it's much better to kind of respect the order as well. Even though if you violate it, is not violating as far as the summation of the sequence are concerned. Okay, so let me talk a few words about the compact sigma notation for those of you who are not for the first time possibly being exposed to that. It's very easy subject. And then I also go at the end discuss in closing lecture about the sequence of partial sum, which plays very important role in a sense. It's very beneficially to recognize the kind of series or sequence we have, in a sense that just does the sequence or the series converges or diverges. The sequence of partial sum can give us a lot of information. Also, the sequence of partial sum, I will be repeating again shortly, is also help us to find some mathematical formula for a finite number of a series that is finite. Now, we also have two different, in general, there are two kinds of sequence and series, finite and infinite. And each of them also, they have, that we will be discussing in this lecture, the lecture that I'm going to upload, are arithmetic sequence and series, we have geometric, we have harmonic, and we have Fibonacci. These four series and sequences are kind of more popular. There are others naturally, but we will be concentrating on these four kind of series and sequences. Okay, then let me put this one up and go over the meaning of summation, which is very elementary in reality for those of you who are being exposed for the first time. Let me do that. May I? Okay, let me zoom this one if I may and stay out of your way so that you can see it better. Okay, near, as I have said, that is a compact sigma notation. Is a compact sigma notation is k equals to 1 to 10, and this sigma notation, which is a Greek alphabet, is it goes from 1 to 10 inclusively. So it starts from 1 and it goes to 10, and we will see that does not really have to start even from 1, and this does not have to be 10. But this number here will be the last when it is finite, and whatever number is here is the first. So this notation indicates that you add 1, then next one will be 2, next one will be 3, next one will be 4, and so on and so forth. It starts from 1 and ends up to 10. So the last word is included. You follow me so far? Now, let me go to second one. Now here is an infinite sums, infinite series. Again, k start from 1, does not have to start from 1, can start from any other mostly positive integer we select, let's say non-negative integers we select, and this one is going for infinite. That is called an infinite series. Again, summation is called, so we are adding odd numbers all together. Okay, then the third one, I leave it to you to see if you can say what the elements of them are. If you can do that, you have got the idea. If you cannot do that, then you have to go back again and pause the video and listen to these two again, and hopefully you will do it for the second time. Now here, I equals to 1 to 7, but notice that there is no I here. So what will be the summations here? So I is going to increase from 1 in inclusive 1 and 7. It start from 1 and ends up to 7, and what will we go here? I leave that one for you to do. And finally, the last one, which is also important to mention, is that these two series are same, even though they look totally different. Meaning that this summation notation that we present for the series, that final series that we represent, the notation of that is not unique. There are other ways to do it. Now let's go over this one. For instance, it goes from 1 to 5. This one starts from 0 to 4. And 0 to 4 also has 5 numbers in there. Starting from 0, 1, 2, 3, 4. There are 5 of them. Now, here I start from 1 to 5. You see that? Now, for instance, when k is 1, this will be 1 times 2 is 2 plus 1 is 3. And here, when k is 0, this is 3. You notice that? And when here k is 5 times 2 is 10 plus 1 is 11, the last one. And here, when k is 4, the last one, is 2 times 4 is 8, 8 plus 3 is 11. You see that? So when we expand this one, putting 1, 2, 3, 4, 5, 1, 0, 1, 2, 3, 4, the numbers that come out of this summation are the same. You follow me so far? Okay, then let me zoom it back and come back to the sequence of partial sum. Okay, now the sequence of partial sum, as I already mentioned, is very, very beneficially, and as the name, the vocabulary name mentioned, they are partial sum of a sequence or a series. So the sequence of partial sum, in other words, can be derived from a given sequence or can be derived from a given series, either of the two. And let's see what I have put them in writing. I guess I put them up for you and go over them. And I repeat again, so it's important. They play a very important role in telling us about behavior of a series or sequence, whether they converge or diverge at the end. So let me also go and put this one up, if I may, and zoom it for you so that I can go, you are more kind of comfortable with that. Okay, here I've written in red sequence of partial sum. So I have a sequence, let's say infinite sequence. It's 1, 2, 3, 4, 5, and so on and so forth. And the corresponding to this sequence is this series. You see that? K equal start from 1, the next one is 2, the next one is 3, which means the summation of all of this. Do you see that? So these two, either the given sequence or given series, they both imply this will be the sequence of partial sum. Notice that I use the word sequence of partial sum. All right, a sequence of partial sum. So the sequence of partial sum of this sequence or the sequence of partial sum of this series will be a start from 1, the next one will be 1 plus 2, next one will be 1 plus 2 plus 3, next one will be 1 plus 2 plus 3 plus 4, and so on and so forth, continue depending on the if it is finite or infinite. So we know what sequence of partial sum is all about. You follow me so far? And also, I have written them in a compact form, and let me also here, I didn't put the K here, you can put it for yourself. Let me do it if I may. So each of them is K equals 1 to 2, as K goes here, and K here, and K here. No, here is exactly the same thing here. You see that? But I put it in a compact form. So for example, this one means 1 plus 2 plus 3. You see that? This corresponds to this, and so on and so forth. It's kind of more compact. So again, one more time, this is the sequence. There is order, and separated by comma. This is a sequence of partial sum of either this sequence or this series. You follow me so far? And also I have let me say also another few words of what we will be seeing for the coming lectures. Let me also okay, that one. And let me cover all this that we don't need and talk about a few things that here. Now, here notice that, let me see if the zooming is okay. Yeah. Now, here the summation goes from k equals to 1 to what? To, let me see if it is focused to there. That's better. Now, this summation, when you go to sequence of partial sum, we can have a mathematical formula for that. And same is true with this one and this one and this one. And the mathematical formula that goes with that, in the lectures to come, I will be going from scratch. We will discover them ourselves, which is a bit different than what I have watched in YouTube other instructors to do, and also some of the textbook I have looked at, that they start from somewhere, but we start from scratch to see where they come from and what was the motive of that. But that will be the subject of the lectures to come. Okay, then let me zoom this one back and okay, then, as always, I wish you all prosperity and good health, and I thank you for watching, and please do make sure you will be watching the other lectures coming about this subject. Okay, then, thanks again, and have a pleasant day. So long.